Okay. So first, let me thank you for your presence as usual. It's our third day for those workshops in order to start the year in good mood. Today, the first day we did the MBOT 2, the robotics with the new robot MBOT 2, which is included in our curriculum 01. Yesterday, we did Arduino and the importance of microcontroller for the lower grades, starting from grade 7. Today, we'll be discussing the issue of the Microbit microcontroller to offer students from grade 3. Why microcontroller is very important? Simply because everywhere, every component we are using, like we said yesterday, all the objects around us, the fridge, the microphone, every electronic component does include a microcontroller in order to handle and to manage those objects. To clarify the issue, as I said yesterday, that when you teach microcontrollers or robotics especially, you have to transmit the message for your students for each level, depending from the age, that why we are using robotics, what are the advantages from learning microcontrollers or any of those subjects. It's very important for us to transmit those values, because those students, once they are in front of an adult, they have to answer correctly in a logical way, let's say, answers regarding those topics. You know very well that parents, owners of schools, friends, academic directors, teachers like to hear students talking about those new technologies. That's why always I like to focus on teaching any new skill, to split it into 3 main parts, different parts. The first part is the environment of the product we are talking about, and then how to handle it in a basic way, to master it in a simple way, to program it, to work with. And so, can you please turn off your cameras, لو سمحتوا? And the third part, which is going further to create advanced projects in STEAM, if we are using robotics, microcontrollers, and other skills. If I want to start with the first level of introduction, which is to identify the microcontroller Microbit and the history of Microbit and why it is created. After all, the Microbit, it's I don't find it, the Microbit, where it is. Okay, the Microbit, this is it. It's a small chip, all right, like 6 centimeters plus minus, maybe more, okay. But this Microbit is leading the educational world for primary school, believe me. And I'll show you later on why and how it is leading. The idea from creating this Microbit came from the problem. It is a British product. It is invented by the BBC. I don't know if you can see. It's a BBC Microbit. Okay. And we all know that the BBC, actually, it's a broadcasting television in the UK. But you have to know that the BBC is owned by the government, and it's an NGO, non-profit organization. And all the profit made by the BBC should be involved in educational, environment, medical, social activities. And when they found that the Arduino board that we discussed yesterday, it's impossible to make it for the reach of lower grades. I mean grade 3, 4, 5, 6, and up, because it demands lots of wiring and lots of electronic concept. Okay, they started thinking about a new product where students can discover the world of the microcontrollers without, as a first stage, without the need of cabling and wiring. And in 2017, I think, or 16, when I was in BET show in London, the show where solution for education and technology are held, it's the biggest show in the world. I think always I talk about it. Okay, I saw kids and students running all over the show, holding a microbit with a battery and displaying messages and I don't know, in the pocket, in the hat, and everywhere, even on the shoes, in order to create those animations. And at that time, I asked, what is this? They told me it's the microbit, and it was distributed for all the students in the UK for £1. Why this is done at that time? Because they believe that microcontrollers should be given for lower grades. And now I think it costs like £12, $15, something like that. It's always cheap. And now we have the version 2 of the microbit, which is, it includes more sensors, a microphone, a speaker, and a touchable logo, the version 2, version 1 and version 2. So once we know that all the concentration of the UK government is made on developing this microbit since 2016-17, now we can conclude, and I'll show you that microbit is leading the world of microcontrollers for lower grades. And beside the microbit, there is an ecosystem, companies in UK, in China, in everywhere, where they started developing extra solution for the microbit. I can give you an example of this. For example, this product, which is the soil moisture sensor, that I can attach the microbit on it. I can plug it in the soil in order to test the humidity and in order to take action for that. I have many products, and in our curriculum, we have integrated many of them. This is the air quality station, where I can plug my microbit on it, as you can see. And students are asked to program the microbit in order to read the air quality station, from the air quality station, humidity, temperature, CO2, pollution, and other atmosphere values and readings. And they can store those data in an Excel sheet in order to create a log file later on. So what I'm talking about is a complete solution for this microbit in order to start dealing with this solution. And then later on, when students reach grade 7, they are ready to understand what are microcontrollers, the input, the output, and then they can start with Arduino. And to tell you that, as we said yesterday, I believe you were with me yesterday, that even for the microbit, it can be handled like the Arduino. I mean, if you take this connector, you can plug the Arduino board on it like this, okay? And all the digital pins are here, so you can take a wire to connect it to a LED, to a sensor, to a pump. So it is like an Arduino, but the advantage of it that It includes push buttons, screen, microphone, speaker, sensors, and other products. Now I'll be moving directly to the practice in order to show you the solutions that are available in terms of programming or in terms of coding. So mainly this Microbit 2. No, it's, I think it's the Microbit version 1, but it's the same. Yeah, the shape is the same, but you can see that there is a small microphone. I want to share with you my screen now, and please tell me on the chat if you are if you can see my my screen. Okay, thank you. So in terms of software, thank you. In terms of software, we have two options. The first option is the Make Code by Microsoft, and the Make Code is available on two versions, the online version and the offline version. And then the Tinkercad that we worked with yesterday. And if I go to Tinkercad, if I open Tinkercad, just 1 second, all right. To prove you that Microbit and Arduino are leading the market on Tinkercad, that we all agree that it is the platform to provide the huge solution for simulation in terms of 3D and in terms of microcontrollers and code block. If we scroll down and we search for the microcontrollers that are available, we can see that we have only two microcontrollers. We have the Microbit and we have the Arduino. Why I'm saying that? I'm saying that simply to tell you that maybe there is companies come to your school and try to convince you why you are using the Microbit or the Arduino. There is another microcontrollers, try this, try that, and so on. Believe me, don't go with this path, since maybe it's good, but as a solution on the platforms, you will not find a support for those microcontrollers. So going from Tinkercad, you can see that it's really clear the Microbit and the Arduino are the two microcontrollers to dominate the educational market. So I'll go to the to go to the make code from make code from Microsoft. So I have this platform, it's online, and I have the offline version, which is the same with a slight difference. I'll tell you later the difference between both. So I will start by a new project. And you can see directly that the Microbit simulator is on the left. So everything you do, as let's say show the icon of the heart, automatically in few seconds the simulator will work and it will show the heart. If I go to let's say pause 100 milliseconds, then play the word hello, so I can click on the play, and then I have the message. Now if I want to go to download it on the hardware, I will try to connect it to my computer, hope it will Okay. So now my microbit is connected to the computer with a USB cable. Okay, I click on the download button. It will take like few seconds. You see it's downloading, and then you will have the heart, and then you will see the word hello. So here, the path of the learning edge that we are going to explore with our students is that they will explore the world of the microcontroller, but at the same time, they will be exploring, let's say, the coding skills in terms of trying them on a hardware like the robot, the microbit, or the Arduino. And this is what makes the ICT and robotics really challenging and really interesting and really in direct connect with the STEAM projects and other topics that we are working with. If we scroll down the different topics, we can see that, for example, we have the basic category, the input category, where it includes all the input like the push buttons, the shake, the pin 0 press, the accelerometer sensor, the light level sensor, the compass heading sensor, the temperature sensor, and the loudness sensor, the logo if pressed. You see it's for the version 2, and the sound level. We can click on the more options to have the rotation pitch, magnetic force, running time, calibrate the Canva, and other blocks. We have the category for the music. We have the category for the LEDs. We have the category for the connectivity radio, the loop, the logic, the if-else with the comparison and the Boolean, the variable. So it's like Scratch 100%, the math, and of course, I have the advanced function that we are not concerned with for the primary grades, but the most important is the extension. And here, I have to focus on this idea that if I click on extension, I will see in the offline version that I have many products listed and other I can search for. So I will try, for example, the lab bit that we have from Kitronic. I'll be showing you later. So we see that I cannot search, I cannot find the lab bit on the make code. All right. So what I'll have to do, and here please focus on this with me, that I have to go to the online version since it's connected directly to the internet. I click on the extensions. You see there is different categories displayed. I will click here. I will search for lab. And directly I'll have on my online version the lab bit displayed. This lab bit is included in our curriculum to show students how input and output devices are connected together in terms of programming and automation. So all I have to do in order to have the lab bit available on my offline version is to click on Learn More. Okay, I will select the driver. I will copy it. I will go to my offline version. I will click here. I will paste my driver, and here the lab bit is displayed, and all the subcategories or sub blocks are displayed, like the input, the traffic light, the dice, the color, the motor. So it's connected already to my system. So I can do the project that I want, but I cannot do a simulation with the extra product from Kitronic or other, just for the microbit. So now there is a very important question I have to ask. It's about what's the difference between the make code and the شو اسمه oh my god, Tinkercad. Okay, so what's the difference between, where is Tinkercad? Okay, so what's the difference between make code and Tinkercad? It's clear that on make code, you can't attach external input and output device to your microbit. Just you can work on your microbit, you can program your microbit, you can create script with advanced script. I will show you in a while. But if you want to attach a LED, a soil moisture sensor, a motor, an LDR, any kind of input-output device, it's not feasible. And I have to tell you also that on the microbit, you can see that you have pins like in Arduino. Yesterday, we said that on Arduino, we have from digital pin 0 till 13. Here, since it's for kids, no need for 13 pins. So I have pin 0, pin 1, pin 2, the 3 volt and the ground. So I will delete my circuit, and I will show you, for example, how to create, even on Tinkercad or on MakeBlock, how to create a counter. If I click on push button A, the counter will be incremented, increased, or on button B, it will be decreased. So I will go on code. I will create a variable. I will name it count, for example. Okay. And on the start, I will set the count to 0. And I will delete this, no need. And for the input, on button A, I will change the count by 1, and I will display the number of the variable count. And I will duplicate all this for B, and I will make it by -1, and I will show the button. So once I click on simulation, you will see that 1, 2, 3, 4, decreasing. Okay, but here I don't have the option to download it on my microbit in order to try it. So same program could be done on the microbit as offline. So I will be creating quickly a variable named count. The variable on start, it will set to 0. And then same program, exactly the same. I will be change count by 1. And then I will display same interface. As you can see, the variable count is displayed. And then if I duplicate, I select the B, and it will be changed -1. And here by simulation, if I click, I can see 1, 2, 3, 4. I have the option here to download it to my look, the download is done now. The LED is blinking to show that it's downloaded. And once done, I will press on button number 1, button number A, 1, 2, 3, 4, 5, and here I can go back decreasing. So as you can see that the manipulation is doable on make code even offline or online, and on Tinkercad. The advantage of MakeCode is that I can download my program on the hardware in order to test it. In Tinkercad, it's just simulation. But the advantage of the Tinkercad platform is that I can add extra input-output devices that I cannot do it here till now. So if I go to the back to the Tinkercad, okay, I can hide the code. I can take my resistor, as we said yesterday. Okay. I can turn it to make it horizontal. It's a small detail. I can link the cathode to the ground and the anode to terminal to pin number 1. Okay, I can add push buttons, any. And then from the block code, let's say, I will change a little bit my code to say that for the output, I will just 1 second to find the digital write on pin number 1 is high, and then wait 1 second. And if I click on button B, it will be low. No need for 1 second, huh? Okay, so now I will start the simulation. And if I click on the button A, the LED will illuminate. If I click on button B, the LED will turn off. And as you can see, that once I click on the run on the microbit, all the sensors are shown on the screen. So I can change, let's say, the temperature. If I did a mission related to the temperature sensor, the light sensor, the shake, compass, if I click on the touch logo and other stuff. So, but here I have to clarify something very, very, very important. In our curriculum 01, we have introduced MakeCode and not Tinkercad. For a simple reason, there is a question? For the simple reason that the MakeCode is dedicated for beginners more than Tinkercad, since here we have external input and output devices, so it will be a little bit embarrassing for students to handle this platform, especially that the MakeCode is offline. This is first. And then I advise you highly not to work with Tinkercad with lower grades. I mean from grade 3, 4, 5, and 6 for the entire class. But maybe if you have a small group of students that are advanced, brave, and you can do with them, let's say, some extra activities in order to prepare them maybe to show some projects during the technology day at school. So here you can work with them on this platform, Tinkercad, in order to maybe use the breadboard, the push button, buzzer, and other stuff with the microbit. And here I believe it will be a nice experience with them. Maybe in the next updates that we are going to do, it's not maybe, it's for sure, once students will be used to handle the microbit on MakeCode, we will develop a special curriculum for the microbit with Tinkercad. Okay, so I believe that I gave you a general overview of the history of the microbit, why the microbit, and why it's leading the market, one. Two, the softwares that we are using in terms of manipulation, like the MakeCode offline and online, and the Tinkercad. Okay. In a while, I'll be moving to the curriculum in order to show you, for those who don't have access to the digital platform, in order to see how the curriculum is light and it's guided, clear, has an educational perspective for teachers and for students. And of course, exploring the teacher guide for those chapters will help a lot teachers to handle this technology. Here, I remind you that for those who are using our curriculum, right click and 01, please do not forget to activate your account in order to get access again to the digital platform and to download all what you have to download. I'll get back to the MakeCode software in order to show you another feature which is very important in the extension, which is the micro turtle. So here we remember all that in all languages, small basic, Python, PC logo, Scratch, there is like a turtle to draw shapes in order to enhance the algorithm skills and the logic for kids. So here, the micro turtle, it's a logo-like turtle library. Once you click on, you will be adding the turtle, and what you have is all the blocks to draw on the LEDs the shape you want. So you have a forward one step, you have back one step, turn left, turn right, set position, X, Y, pen down, and so on. So let's try, for example, to try a simple mission. I don't know if you are trying with me, but with the turtle, I click on pen down, move forward one step. Okay. If I click on run and I click on the button, sorry. Sorry, to change, show, all right. Okay, no need, all right. So you can see that it's moving one step. And here, you cannot imagine the scenarios that you can ask for students by implementing and integrating the variables and the logic for the brightness, for the speed, for the looping system, for the if. So you will be having on the platform also additional extra lessons for the turtle in order to enhance skills for students in drawing shapes using the microbit. And here, of course, we can explore. So if I click on download, so few seconds, and then if I click on the button B, you can see that I'm drawing on the microbit screen, like in Turtle. I draw a line, and once I exit the screen, I started from down. So I believe that this introduction will help you a lot in order to understand all the aspects of this software and the environment of the software. Of course, the content of each category, it's about coding, and I believe that you are professional, you are masters in this field. But now I will try for like 10 to 15 minutes to show you the curriculum or the chapter. There is a question, I think. Okay, you are asking how to buy this kit. Actually, there is many online stores to sell, and very soon, the agent of the MBOT who was in Dubai, now he opened a shop in Saudi Arabia. He is providing the MBOT 2, and he is providing also Arduino and Microbit. But I will note in order to do my research to find local supplier, and I can help you by sending a list of providers, Microbit and Arduino. So for the grade 3, okay, for the grade 3, I have a chapter for like 5 to 6 sessions, not more. No need for more, just to understand the concept of this microbit. So I will start my first lesson. You can see that you can see that the interface of the 2 pages, it's very simple, very clear, not too much writing, in order to let students work more on this device. So quickly, teachers are asked to show or to make students understand that on this microbit, I have a screen where I can show pictures or messages or numbers. Okay, you will have to explore with them the make code, even if it's online or offline. Both addresses are on our platform, and then let them explore the basic blocks that they have from showing numbers or from showing messages or showing or writing messages. And then you will ask them to create a simple project and to have some fun with them. And of course, you can explore. We will be hosting on our platform, inshallah, very soon, ideas for projects with Microbit on our digital platform. The second lesson will be to handle the arrows on the microbit. So in the lesson, you will create project to use the microbit to guide you while walking a path. Examine how an arrow is displayed on the screen of the microbit. So guide your friend to walk through a path in order to reach a target point. So here he's asked to hold the microbit in his hand and to follow the messages and arrows to move. So you have to create what we call a sequence of blocks with the arrows and split it with time. And then after, students will hold the microbit and will move according to the arrows shown on the screen. Then after, we will ask them to display letters on the show LEDs where they can illuminate the LEDs they want. And at the end, display on the screen of the microbit the name of 3 items that we can recycle, place a pause block between the messages to be able to read them. So here we are like trying to link the sustainable development goal by the United Nations with the teaching of ICT and robotics. Instead of asking the students to display any kind of information, so no sense. So here there is a guided project. So please show me, for example, all the items that I can recycle. So they have to discuss, they have to ask, they have to be guided for that. And for the lesson 3, here we talk about the to display music, since we have a speaker on the microbit. So we can create from the category music, let's say special notes or special display. And then with the help of your music teacher, create a musical note to express best wishes for your friend on his birthday. So here you can create some music, funny music, in order to play it. In lesson 4, I believe it's it remains 2 lessons. We work on the push button in order to control, as I showed you before, to control the messages by clicking on button A and B. And on the right page, we are asking students to make a research or to look at the pictures on the right in order to list animals that we can find in the jungle, in the desert, or in the sea. And later on, we will ask students, if I press on button A, please show me the name of an animal I can find in the jungle. If I press on B, name of an animal in the desert. And if I press on both A and B, it will show me an animal in the sea. So here also, we try to link the projects to what we call related real-life project. And finally, we can create a game by using the block show number with the block pick random. And here, the computer or the microbit will display a random number on the screen in order to create, let's say, some game or adding score or other stuff like this. If I go through the lesson, lesson for the grade 4, I can see that here, of course, it's a little bit advanced. We can start discussing the issue with our students in terms of real-life projects, okay? And then after, we will go through. So you will see that the first page, it's like a revision of the previous year. So describe the mission number 1, describe the mission number 2. So here you will ask me that what if in grade 4, the students in grade 3, they did not have the microbit in their curriculum. It's okay. You can do like 1 or 2 sessions in order to make them a recap, and then after they will start with their book in grade 4. So they have to describe the two missions. Then how to run the program, make code, the offline version and the online version. And then students are asked to do a project. And then here we will link them to the real world, that the microcontrollers are around us, where we can find a microcontroller. We give an example for the fridge and for the lift. There is a project to do. And then after, we'll start with displaying some shapes with complex project and to describe the use of those blocks that appear on the right. And then we start with the sensors. And here, sensing your step, counting the sensors, defining a sensor, the temperature sensor, and then we will do a project with the temperature sensor on the microbit. On lesson 4, we define a variable. Always you see that the lessons are attractive, with less text, with too much animation, with oriented projects. So believe me, your students and you will enjoy those chapters. Here we are working with the push buttons, including the variables, as I showed you before, how to change the value of a variable by clicking on push button A and B, and then reading the temperature, drawing with the micro turtle, as I showed you before. And then we integrate the lab bit on lesson 7 for the grade 4. So how to download the extension, what we can do with. So with many projects that you can explore easily on our curriculum and on our digital platform. I believe that we covered the main topics regarding the this issue. I hope that you have a clear idea about. Of course, I will be sending you all the recording session. So here I'm sending the Google form to fill it in order to receive the certificate of participation. Okay. And if you have any question, I'm here to answer. And if till now your school did not decide for a curriculum to adopt, we are here to help you. You can send us an email or a WhatsApp, and we can help you in providing specimen or access to the platform in order to look closer to our curriculum. So I hope that you will be filling the and here my friend Muhammad Hamdi is asking if you have if you are free, or you know one of your colleagues that are